involved in several student-led campus greening initiatives on their campus. Students are the biggest energy users on the campus, so they need to be empowered and understand that they are the ones that will need to help drive the energy use down on their campus for this to work.
Tell us more about the programs that you like or that you use.
Yeah, well, one thing that we did at Middlebury, we ran a program called Mid 68. It was about 68 degrees, trying to get everyone to turn down their thermostat in their house 2 degrees from not their house, their dorm or their office or wherever. And it was like fun and funky, and we had little posters that said "Beat the Heat" all over the campus, which was cool. And I think it's one of those like easy lifestyle changes that you can do super quick. Another thing that happened at Middlebury was the Step It Up Days of Action actually started at Middlebury. Step It Up was this giant political push to try and get the words 80% by 2050 in every politician's mouth. So in addition to like green living, we're trying to get people to get politically active as another part of like greening your life.
Sure, absolutely.
And I think we were really successful in mobilizing folks all around the country. And then when President Barack Obama was elected, it was essentially on our talking point. One last thing that I think was really cool was like a competition that we had on campus that was called Power Strip. And it was how much can you take off? It was kind of like sexy, funky. And the point was how much energy can you save in 1 week versus whatever everyone else on your freshman hall can save. The
back of the panel, it just mounts onto that mounting strip, and everything's on a 30-degree angle, so we have gravity really working for us to make the system work. Gravity helps hold the panel in place, gravity pulls the water down through it, but the panel does retain a certain amount of water, so we're not losing all the moisture every time we applicate, so we can go longer cycles without irrigation. Basically, there's an emitter line that runs in front of the collection chamber, and it bleeds water slowly into the system, and then these notches that you see in the panel allow the water to move down through it. And there's a drip edge at the bottom, so we have good drainage as well as water retention. And this actually will drain either into the panel below it, because this drip edge nests nicely in front of the collection chamber, or at the bottom panels there's just usually a drain detail or a water collection detail that deals with any excess water. There's not a lot of water that goes through it. We don't want to be really like wasting water. We just want to make sure we have enough water to saturate the panels. For exterior applications, we're using either succulents or grasses or basically exterior landscape vegetation.
And about how much does this cost per square foot to install?
The system generally starts at about $80 a square foot. It can be as much as $150 a square foot, depending on what the application is, what the plant spec is.
We're trying to get some footage for our blog. If you're willing, we'd love to hear you talk about the product.
Well, it's electronically tintable glass.
Okay.
It gives you the ability to go from 62% visible light transmission to clear state. It is, at this point, a spectrally selective low-E product.
Okay.
Whenever the sun becomes an issue, which could be 20% of the time, you can go to the tinted state.
Yeah, that's very, very tinted.
Which is 3.5% visible light transmission, and more importantly, a 0.09 solar decay coefficient. So this product actually gives you the flexibility to simplify your designs and have a two-prong attack. One is to make sure that the building is energy efficient, sage glass blocking out the solar sensible load to the space has dramatic effects on the HVAC. Secondly, and what's probably more important, is the people aspect. How do we keep them comfortable and connected to the outdoors? See, this design here is a solution to a sun problem. It's not a solution to a building or the people inside. This is one that does both. And it's less expensive.
How much is this compared to a standard insulated glass?
It's 1.5 to 5 times more expensive. That's today at the volumes we're at, and that's going down every year. We've been having it seems, every year it gets cut in half due to our volumes.
What is the name of your company?
Sustainable Flooring.
Okay, great. And I see you have some cork products and some rapidly renewable fibrous products. So could you tell me a little bit more about what's here?
Sure. Yeah, what we do is we specialize. We do specialize in flooring and panel and interior finish products. We have three main product categories. One is rapidly renewable, which encompasses cork and bamboo.
Okay.
One is certified woods.
Yes.
And another one is byproduct wood species, where we take byproducts from other industries and we use them in the production of our products.
Excellent.
And what you see down here is a rapidly renewable and byproduct product. It's post-industrial wine corks, which are cut into discs, such as this.
That's really interesting. I've never seen anything like that before.
And then you grout them. You can either use an epoxy or sanded, and we're going for we're shifting to a urethane modified grout, so it's flexible, and it's like an epoxy, but it's much easier to work with. It's suitable in wet applications, floor and wall. Then we also deal with compressed wood products, the byproducts, which I mentioned. And this, well, I'll show you this. This is a sample of 100% byproduct wood waste from the furniture manufacturing.
Wow, that's beautiful. So this is normally something that would have been sent to the landfill.
Correct.
Wow.
Here's wood scraps.
Okay.
From the furniture manufacturing industry.
Okay, sure.
Which we compile and compress into this. It's a very dense, really heavy log.
Wow, that's interesting.
And then we mill flooring out of it.
That's beautiful.
And then, so this is the vertical cut of the product. When you turn it on its side, you get the vertical cut. It's much more linear, which is up there. The second.
Okay, sure.
The one in between the black and the white one?
Sure, yeah.
So it is a different look.
Beautiful grain.
And it's very hard and stable. We also take mulberry branches.
Okay.
A byproduct from the silk industry, where silkworms eat the leaves, they make silk, then they have to harvest the branches every year, so the leaves will regenerate, so more silk can be made. And we take these branches,
yeah, I feel that. Interesting.
compress the daylights out of them into the same sort of block.
Okay.
And here's a mulberry flooring.
Wow, that's beautiful.
And then these are all the natural colors, and when you apply a stain, like these ones right here, it mutes the craziness of the color.
Wow.
Because this is relatively wild.
Sure.
But again, it's really hard, really stable.
Harder than red oak?
It is over twice as hard.
Wow, that's amazing.
And another thing we're doing is we're infusing color into the same process. You can take a look at that with your fancy camera.
Yeah.
And you'd see that it has the same grain and pattern, but what we're doing is we're infusing color into it. So if you look at the end, it's solid color throughout.
Wow.
So if you nicked it, sanded it, you never need to stain it again.
Interesting.
And since it is so hard and stable, the likelihood of needing to resand it and restain it and all that kind of stuff is minimized. So the life cycle savings.
Yeah, life cycle, absolutely. And this seems like it functions more like a solid hardwood than an engineered product.
It's both.
So you can, it's both, and that means that you probably have many more opportunities to sand and refinish this product throughout its lifetime.
Well, the reality is it's so hard that you'd less likely ever need to.
Even better, absolutely.
Yeah, I mean, it should last indefinitely.